Okay, let's think pictorially how we could come up with the area of a circle. So, first thing, let's cut this thing in half. Then let's separate these two halves a little bit. Okay, and now have a top and a bottom half of a circle. Now, let's go and section these like section of an orange or a tangerine, cutting it up like a pizza with 8 slices. Okay, the next thing we're going to do is we're going to pry open these sections so that the outer circumference is a straight line. So with them opened up like this, they kind of look like teeth or wedges of a tangerine that you've pulled apart. So I can now take this top section and fit it into my bottom section. And it doesn't quite perfectly fit, but it comes close. And because it doesn't quite perfectly fit, although it looks like this might be a parallelogram, that's not really the exact solution to this problem. So what we have to do is we have to do something that's real similar to what we do in calculus. And the Greeks actually understood how to do this sort of thing. So they kind of had a rudimentary form of calculus. But what I'm going to do is let's pull these apart again. I'm going to add more triangles. First, let me copy this and paste it down here or so. So if I double the number of wedges, my opposing teeth will look like this. And we see that when I take this and I slide it down here, now it's starting to fit a little better. Still some error, but what's happening here, one thing that's happening here now is this angle here is getting larger, and this line here on this edge, and the same thing on this edge, is starting to get more vertical, closer to vertical as I get more and more of these. Now, one thing that I wanted to mention, this distance here is half the circumference. And of course that distance is 2 pi r. And if it's 1/2 of that, it's 1/2 times that, which means the distance is pi times r. I've got my timer down here in my screen. So when I pull this open, the length of this bottom edge is pi times r. Let's keep that in mind. So let's really increase the number of triangles here. First, let me move this. Oops. Let's move this up out of the way again. Okay, so now I have a lot of triangles. Looks like a comb over top of another comb. And I can take this. Oh, rats. Let's try that again. I can take this. I can squeeze it in down here. And now we're getting something that looks like a rectangle. And what's interesting is the bottom line here is still 2 pi. The base here and the top are still equal to the length of 2 pi, or pi r, I mean, just like I have up here. Let's scroll up a little bit so we can see this stuff. So this bottom length is still pi r. Top length is the same, so this is like a rectangle, pi r. And this distance here is essentially the radius, because each of these sections starts at here is only a radius long. Each of these pieces is only a radius long. So these are a radius. So this is a radius. So the area of a rectangle then is base times height, or pi r times r equals pi r squared. So that's kind of like a calculus type approach to figuring out what the area of a circle is. Well, let's try an example. Suppose I have a circle here with radius 10. Then the area of my circle is just pi times r, which is 10 squared. Which is 100 pi. We can leave this problem like this because turning pi into a number on your calculator and multiplying by 100 will give you, well, I'll go ahead and do that. Here you see it just gives you an infinite number. And so here I've done that calculation. You can see it's just an infinite number. So if I paste that here, so this is not necessarily written any better. We could make an estimate, 314.2 maybe, depending on how much accuracy we need. But if we just write 100 pi, that's 100% accurate. And I'm perfectly okay with you doing this, leaving this as 100 pi on a test. And that's it.